This video provides a quick review of our published paper, HiMo, High-Speed Object Motion Compensation in Point Clouds. First, let's explore how data distortion occurs in point clouds. Here is a simple animation to illustrate a common type of distortion we meet, ego motion distortion. As you can see, when we move quickly, the data from a single frame get distorted due to our arm motion. When we apply the ego motion compensation, the data can correctly represent the environment again. Now let's check the distortion in the real world. Note the clear distortion in the static structure. Here is a brief sequence demo from our highway dataset. We will pause at one frame and compare the scene before and after ego motion compensation. As is well known, this is a standard process during vehicle operation or before a researcher published their data. But this leads us to an important question: what happened to the motion of non-ego vehicles? We will present the second animation to demonstrate how distortion is occurred by other high-speed objects. As you can see, when we increase the speed of other objects, the distortion caused the behind object to be split in half. This distortion becomes apparent after a full 360-degree swap, as shown in these two figures. Now let's revisit real-world data from the zigzag open dataset, which has already ego motion compensated. Note how the truck's front end is split into two parts in one frame of the point cloud. Now let's consider if we have additional LiDAR. At first, when nearby objects are moving slowly, distortion might be hard to notice. But what happened if they move quickly? In that case, not only a vehicle appears split, but there can also be multiple copies of the same object. Here we present a real data example from Argoverse 2 public dataset. In this case, there are two LiDAR strategies start at the same time step but with sensor oriented 160 apart. This sequence include data with ego motion compensation already applied. Let's pause at one frame and explore it further. As shown in the video, within a single frame, multiple copies of high-speed objects are present. Multi-LiDAR are equipped in our heavy vehicle to avoid self-occlusion. This one demonstrates distortion caused by motion of other objects, which depends on the velocity of different objects. In such case, ego motion compensation alone is inefficient. Finally, we will showcase the result from our HiMo pipeline experiments. Detailed method and comprehensive analysis can be found in our paper. Motion distortion occurred in all public datasets that contains moving objects in the scene. Here, we present results from three datasets, including highway dataset collected by our heavy vehicle and two public datasets, Argoverse 2 and zigzag open dataset, zoned. Here is the data we collect. Different colors represent point clouds from separate LiDARs. On the left is the raw data with ego motion compensate, and on the right are our HiMo results. Next, we present the result from Argoverse 2 dataset, clearly demonstrate the effectiveness of our HiMo pipeline. Finally, here is a HiMo result to undistorted data about half-card vehicle as shown earlier in the zigzag open dataset. For more details and results, please refer to our HiMo paper and project page. Thank you for your watching.